When you talk about calories, you're only measuring what passes your lips. You don't really care. What you care about is what passes your intestinal border. Well, those two are very different.
Absolutely.
Well, then a calorie is not a calorie, is it?
Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Dr. Gil Blander. Welcome to Longevity by Design, how to live longer, healthier life. We are produced by Inside Tracker, your science-based guide to optimize your body from the inside out. Our guest today is Dr. Robert Lustig, who will discuss his work focusing on the impact of ultra-processed food and fructose on metabolic health. Robert is an emeritus professor of pediatrics in the Division of Endocrinology and member of the Institute of Health Policy Studies at UCSF. He is a neuroendocrinologist with an expertise in obesity, diabetes, metabolism, and nutrition. He is one of the leading of the current anti-sugar movement. He has dedicated his retirement from clinical medicine to help to fix the food supply and to reduce human suffering and solving the environment by interacting with all stakeholders to bring them together around the common vision of metabolic health, protect the liver, feed the gut, and support the brain. He graduated from MIT in 1976 and received his MD from Cornell University Medical College in 1980. He is the author of popular books such as Fat Chance, The Hacking of the American Mind, and Metabolical. He is the chief scientific officer of a nonprofit, Eat Real. He is on the advisory board of the UC Davis Innovation Institute for Food and Health. Thank you so much, and welcome to the show, Rob.
Thanks very much, Gil. Pleasure to be here.
Thank you so much. And we always start the discussion by a bit of a background, and I would like to start with, why have you decided to be a physician, a clinician, a scientist, and
Well, I could give you the easy answer. It's because my grandmother made me. I remember when I was 10 years old, it was a Passover dinner, and I remember my parents saying to me, "Bobby, you can be anything you want to be just so long as you're happy." And my grandmother piped up from the back, "But a doctor makes so much." What she didn't realize was academic pediatric endocrinologists don't make so much money. And that was actually a sticking point for my mother my entire career. She told me back in 2000, "You're snatching defeat from the jaws of victory," because I went into academia and couldn't buy her condo on the French Riviera. Did it because this was the easiest way to help people in a way I knew how.
That's great, yeah. And I can tell you about my story. When I decided not to become a professor in the academia and move to the industry, my mom was very disappointed, and she found a way to show it to me a few times. "Why can't you be a professor? I was dreaming that you will be a professor." So I feel similar to you.
Maybe your mother should have talked to my mother.
Yeah. Both of them are Jewish moms, so it sounds like them.
There you go.
And what drove you to be interested in obesity, diabetes, metabolism?
Well, I'm a neuroendocrinologist,
Yeah.
so how the brain controls hormones and how hormones control the brain. I've
Yeah.
been interested in this really since 7th grade.
Wow.
Because in 7th grade, it was 1968, and I remember I had to do a science project in 7th grade science, and Guillermin and Shally had just isolated the first hypothalamic releasing factor, TRF, okay, thyrotropin releasing factor. And I thought, wow, the brain controls thyroid, and it's postulated that the brain controls everything else. This is really interesting. I did my term paper on that topic, and I just stayed interested in it for the rest of my life. Ended up studying it. I did the med school endocrinology course during MIT, Health Sciences and Technology, the Harvard MIT program, and ended up becoming a pediatric endocrinologist in part to understand how this brain hormone connection worked. Obesity turned out to be the final frontier of this. And the thing that made it very clear was the discovery of leptin. When leptin was discovered in 1994, that basically solidified the fact that obesity was not just about behavior, it was about biochemistry. And I was at a unique place because I was working at St. Jude Children's Research Hospital, taking care of kids with brain tumors, because they have lots of endocrine problems because of the hypothalamus and pituitary being knocked out. Well, it turned out a lot of these kids became massively obese because of the tumor or because of the treatment, whether it was the surgery or the radiation. And I was in charge of their care. And I had to figure out what to do about the fact that these kids who were previously normal weight were now 350 pounds. Well, I knew, because of my neuroendocrine training, that if you take an electrode and you put it in the hypothalamus of a rat and you buzz it, they start eating like there's no tomorrow and they gain all of this weight. This was called the VMH lesioned rat, the ventromedial hypothalamus lesioned rat. And the other thing we knew about it was that if you cut the vagus nerve, so the nerve going from the brain to the pancreas, their insulin levels did not rise like otherwise, and they didn't gain. Leptin had just been discovered. I postulated that these poor kids could not see their leptin because of the brain damage, so that their brain thought they were starving, so therefore they were releasing more insulin through this vagus nerve, and that was what was driving the weight gain. How could I fix it? How could I stop it? Well, I can't cut a vagus nerve. I'm not a surgeon, but I had something almost as good. I had a drug that could suppress insulin release called octreotide. So we did a pilot study where we gave octreotide to these kids with hypothalamic obesity in an attempt to suppress their insulin. And lo and behold, these kids started losing weight.
Well,
and not only did they lose weight, but they started exercising spontaneously. One kid became a competitive swimmer. 2 kids started lifting weights at home. 1 kid became the manager of his high school basketball team, running around collecting all the basketballs. These were kids who sat on the couch, ate Doritos, and slept. These were lumps on a log. And the parents would describe them and say, I've lost my kid to the therapy. They survived the tumor only to succumb to the therapy. This is double jeopardy. This is unfair. And it was up to me to do something for them. I did something for them. And they got better. So we did that in a double-blind, placebo-controlled fashion and showed the same thing. And then we asked the question, could there be adults without brain tumors who have this phenomenon of not being able to see their leptin, releasing too much insulin, and driving their weight gain? And would they respond to insulin suppression with this drug also? So we did a pilot study in adults. And lo and behold, of the 44 patients we treated, 8, not all of them, certainly not all of them, but 8 out of the 44 lost enormous amounts of weight, just like the kids. And when we looked at their insulin responses, they did the same thing that the kids did. We had found a subset of obese individuals that had a very specific and stereotyped pathology and mechanism, and we found a treatment for them. We had basically started parsing the obesity syndrome, because obesity is not one disease, it's many.
Yeah.
We found one, and we found a treatment for it. Phenomenal. Well, that got me started on my road in obesity research back in 1995. And then I asked the question, well, that's great for the 8, but there were 36 that didn't respond.
Yeah.
What's wrong with them? Well, they didn't have this insulin secretion problem. They had an insulin resistance problem. And so the question was, what's causing their insulin resistance? And that's where this concept of sugar came. I was sitting in a lecture here at UCSF. I've moved to UCSF in the meantime. I was sitting in a lecture, and an investigator from UC Davis, Peter Havel, was giving a lecture on fructose, and I said, wait a second, fructose is a very specific driver of liver fat. And these kids now all have fatty liver disease. Could fructose be the seminal stimulus to this hepatic insulin resistance? And so we looked at this question, and sure enough, this turned out to be the case. We ended up doing multiple studies to demonstrate that. So that got me into sugar. Well, then the question was, all right, if it's the sugar, then what do we do about that? And that got me into public health, and that got me into law, and that got me into entrepreneurship, trying to actually come up with methods for fixing the problem. And it got me into the nonprofit space, and here we are.
Yeah, no, very exciting story, and definitely interesting background. My next question, or my first question actually, is a calorie. And does it matter if the calorie comes from one kind of macronutrient or another?
Right. I'm famous for saying a calorie is not a calorie, in the same way that Magritte famously said, this is not a pipe.
Yeah.
A calorie is a unit of physics. It says it is the amount of energy that it takes to heat 1 gram of water 1 degree centigrade. A calorie should be a calorie, because if you heat 1 gram of water 1 degree centigrade, you have expended 1 calorie. And that is true on the energy expenditure side. But the thing about human obesity is it's not just energy expenditure, it's energy intake too. Okay? It is true that a calorie burned is a calorie burned. That is true. But a calorie eaten is not a calorie eaten. And the reason for that is because not all calories are absorbed the same.
Mm-hmm.
Not all calories generate the same insulin response. Not all calories generate the same satiety signal. Not all calories are handled by the microbiome the same. Not all calories are packaged with the same micronutrients. So it turns out that a calorie eaten is not even remotely close to a calorie eaten. And this has now been shown 50 ways from Sunday. And the person who showed it most recently in sort of a QED nail-in-the-coffin way was Kevin Hall in 2019 in his famous Cell Metabolism paper, where he basically locked people up on his clinical research center at the NIH and fed them basically the same food except one ultra-processed and one non-processed, and found that when they ate the ultra-processed food, they ate 500 calories per day more and gained 2 pounds over 2 weeks, as opposed to the opposite. When they ate the non-processed, they ate 500 calories per day fewer and lost 2 pounds per day. So clearly, same food, but whether it was processed or non-processed had a lot to do with whether or not those calories actually contributed to satiety, whether they contributed to adiposity, whether they contributed to weight gain, whether they contribute to insulin response, etc. So the way I phrase it is, if you're talking physics, a calorie is a calorie. If you're talking anything else, a calorie is not a calorie.
Yeah, and but what you're saying that processed food is less filling than unprocessed food, and it's maybe stored more than unprocessed food.
Well,
correct?
it's more than that. It's more than that.
So let's go. Let's double click on that.
Okay, let's double click on that. Here's sort of a salient piece of information. Body temperature, which is basically heat production, which is basically mitochondrial function, because that's where you get your heat from, is basically what your mitochondria generate, but you can't turn into ATP. That's your heat. Body temperature in this country has gone down by 1.5 degrees Fahrenheit over the last 150 years.
I don't know. I didn't know that it went down.
Very clear. If your mitochondria are working, why did that happen? Second issue. Animals in captivity eating the same chow, as always, have actually gained weight over the last 25 years. If they're eating the same chow.
So you mean this? What kind of animal is it?
All.
Like
Every
dog?
animal. Dogs and cats and prairie voles and rats and gorillas and you name it. They all are gaining weight over the last 25 years in captivity.
Yeah.
So it's not like their exercise
Yeah.
changed. Why?
I don't know.
Food didn't change. Why? All right. These are things that, have to be answered.
Yeah.
Okay. Now let's take one more piece of data. We don't just have an epidemic of obese adults. We don't just have an epidemic of obese children. We don't just have an epidemic of obese toddlers.
Yeah.
We now have an epidemic of obese newborns. 4 studies, Russia, Israel, South Africa, the United States, over the last 25 years, an increase of 200 grams of birth weight in those 4 countries over the last 25 years. And when you do the DEXA scanning on those newborn babies, it's all fat. These babies weigh a half a pound of fat more than 25 years ago. They didn't diet or exercise.
Yeah.
How do you explain that?
Something that came from the mom, I assume.
Well, yeah. Okay. Something came from the mom. But what did it have to do with calories? So this is the problem. We have a lot to answer. Okay. And the energy balance model, which is basically what we call calories, okay, can't answer any of those questions. So I think the energy balance model is partial. Now, there's another model out there called the carbohydrate insulin model. And it says that refined carbohydrate and sugar generate an insulin response, and insulin generates adiposity. Now, I was in that cadre. I was in that tent for pretty much my entire obesity career because of the work I did in these children. So I basically told you I believe in insulin being the driver of adiposity. So I was there. But that didn't answer the newborns. Something else was going. So it's also partial.
Yeah.
It's not wrong, but it's not a complete explanation. Well, there are 2 more models. One's called the obesogen model, that there are chemicals in the environment that actually contribute to adiposity. Okay, like for instance, BPA, bisphenol A, which is an estrogen, chlorpyrifos, which is an insecticide, parabens, which are in cosmetics, air pollution, which you breathe, PFAS, polyfluorinated alkylated substances, Teflon, okay, which is in all of our bakeware, DDT, which was an estrogen, Rachel Carson, etc. And there's a host of obesogens. Well, they drive adiposity, having nothing to do with calories. Why? Well, one thing that all of these obesogens do is they generate increased reactive oxygen species in the cells. Everything that generates adiposity generates increased. So obesogens drive adiposity. And then finally, there's a 4th model. And this was developed by Barbara Corky at Boston University, who won the Banting Award several years ago from the American Diabetes Association. And she showed that redox potential within cells. Redox OSs are signaling molecules. They basically tell a cell whether to switch phosphorylation status on important enzymes. Well, the 3 enzymes that are most important in cells for burning versus storing are these 3. PI3 kinase, phosphatidylinositol 3 kinase, which was discovered by Lou Cantley when he was at Beth Israel and is now at Cornell. And he knows that we've shown that's the cancer enzyme because it's opening the spigot to the cell to bring in more glucose because cancer cells don't need oxygen. They don't need mitochondria. They basically don't burn glucose. They ferment it. And then they use the fermentation products to build new cells. The second enzyme is AMP kinase, adenosine monophosphate kinase, which is the fuel gauge on the liver cell to basically make more mitochondria. This is what exercise basically generates. Okay, so when your AMP kinase is turned off, you are not burning energy because your mitochondria are basically turned off. And then finally, the third one is mTOR, mammalian target of rapamycin, which basically tells the cell to divide because it has all the energy and all of the building blocks and
A
structures it
protein
needs.
sensor.
It's a protein sensor.
Yeah.
Exactly right.
Yeah.
That's why protein is associated with cancer. Okay. Well, when these three enzymes are lined up in one direction, you get cell growth. When these three enzymes are lined up in the exact opposite direction, you get cell burning. And when they are not lined up in the same direction, when they are dysynchronous from each other, that's when you get disease. That's when you get metabolic syndrome. That's when you get inflammation. That's when you get early aging.
Yeah.
This has been shown with transgenics. The point is, the ROSs are the switch for those three enzymes. So what we did, we published this in International Journal of Obesity in January of this year. First author, Heindel. So it's Heindel, Lustig, Howard, and Corky. Is we put these four models together and generated a unifying hypothesis of obesity, having to do with whatever raises ROSs. And it can be the food.
Mm-hmm.
It can be the total quantitative caloric allotment, or it can be the obesogens. You generate more redox, you generate more ROSs, you turn the switches in the other direction, and instead of burning at the level of the mitochondria, instead you turn the mitochondria off and you generate adiposity at the same level of energy substrate. It has nothing to do with calories per se. I mean, calories can influence the redox component. Of course it can. But it's because of the redox, not because of the calories.
Got it. And you mentioned ultra-processed food. So can you elaborate about that a bit and what the impact of ultra-processed food on health?
Every study that's now been done looking at this has basically shown an association, and correlation is not causation, and I understand that, but between ultra-processed food and all the morbidities and now mortality that we are seeing in the world today. Now, what is ultra-processed food? My colleague, Dr. Carlos Monteiro, who is a public health epidemiologist at the University of Sao Paulo in Brazil, came up with this after a meeting that we went to in 2011 in Lima. We were discussing this. And he took this home and said, let's divide food into the degree of processing instead of the number of calories. And let's see if the degree of processing makes a difference in terms of disease and obesity instead of the number of calories.
Mm-hmm.
And so he developed this model, and he then vetted it and validated it with numerous data sets from around the world. Okay, so France and Germany and Italy and United States and Israel, a bunch of other places.
Yeah.
He calls it the NOVA system, Portuguese.
Yeah.
And there are four classes. The easiest way to explain the NOVA system is with an example. Let's take an apple.
Okay.
NOVA class 1 would be an apple picked off a tree. NOVA class 2 would be apple slices, destemmed, deseeded, maybe deskinned. NOVA class 3 would be apple sauce, macerated, pulverized, heated, potentially with a preservative added, maybe with even extra sugar, possibly. NOVA class 4 would be a McDonald's apple pie. Now, is there any NOVA class 1 apple in that NOVA class 4 McDonald's apple pie?
Not sure. Maybe not.
Only McDonald's knows for sure. And they're not telling.
Yeah.
Okay. Turns out when you do that and when you look at what people eat, only the NOVA class 4 grouping generates any signal for metabolic illness, for chronic disease, whether it be type 2 diabetes or hypertension or dyslipidemia or cardiovascular disease or cancer or dementia or Crohn's disease for that matter, or fatty liver disease or polycystic ovarian disease or autoimmune disease in general. Okay, only NOVA class 4,
So even
processed food.
So even apple sauce that came directly from apple is as good as apple. There is no difference between raw apple and the apple sauce.
That's right. in the NOAA
Interesting.
system.
Interesting.
Very important,
Yeah.
I think. Now, the food industry is absolutely dead set against this and have done everything they can to torpedo this idea, because 67% of the food 73% of the food in the American grocery store is ultra-processed, and 67% of the sugar that children eat is in ultra-processed.
Yes, absolutely.
So this is a very big deal in terms of their largesse. And so they do not want this to be true.
Yeah.
And so they are doing everything they can to scuttle it. But in fact, every single paper that comes out, and another one just came out 3 days ago, it's in BMJ, looking at mortality. And so ultra-processed food predicts a 4% increase in mortality.
No, I think that it makes a lot of sense, and we see it with our user at InstaTracker. You see that everything that comes from a package that is not natural, you have a higher impact on a bad blood biomarker. Your glucose become higher, inflammation become higher, all the lipids are going higher. So I think that makes a lot of sense, and I think that I agree with you that there is a problem with that, and that's driving to the next question about policies. So what is the influence of the big food industries on the policies and on what the government is demanding or not demanding?
Well, at the moment, no government is demanding anything.
Okay.
We're not up to that yet. They're just in the process of being educated. I am very aware of what's happening at the level of government, but nothing has actually happened yet. Okay? There are a lot of thoughts. There are a lot of, shall we say, rumblings. I have spoken with several members of Congress. I have spoken with several former members of Congress about this and what to do about it. But nothing has happened yet. Now, in terms of what could happen, one thing that has happened for sure is soda taxes.
Yeah.
Okay. Because of the various things in ultra-processed food, the thing that has been very clearly not just shown to be correlated but causative is sugar.
Yeah.
Okay. Sugar, ultra-processed food is high sugar, low fiber, low omega-3s, and lots of emulsifiers.
Yeah, and I assume that also fat and some salt.
Well, there's also high omega-6s, right? There's a bunch of things that are different.
Yeah. It's a lot of bad stuff, Doc.
Yeah, food additives and dyes and what have you.
Yeah.
Okay. But all of the things that are different about ultra-processed food have been associated with chronic disease.
Yeah.
But the only one that's actually been shown to be causative is sugar. So we have data for causation for sugar and 4 diseases: type 2 diabetes, fatty liver disease, cardiovascular disease, and tooth decay.
And one clarification question. When you're talking about sugar, that's additive sugar. So if you eat, I don't know, berry that have sugar, but it has so much fiber that it's offset it, correct?
Exactly right. Because fiber limits the absorption.
Yeah.
Okay. Fiber makes the sugar in natural food not for you.
Yeah.
It was for your bacteria. It was for your microbiome.
Yeah.
Another reason why a calorie eaten is not a calorie eaten, because if you ate it with fiber, the calorie wasn't for you.
You eaten it, but not all of it absorbed in your body.
But so when you talk about calories, you're only measuring what passes your lips.
Yeah.
You don't really care. What you care about is what passes your intestinal brush border. Well, those two are very different.
Absolutely.
Well, then a calorie is not a calorie, is it?
Yeah. It's not. The calories that are put in your mouth is not the same calories that go to your gut.
Well,
and
then
to
a calorie is not a calorie.
Yeah, no.
QED, I rest my case.
No, I'm not arguing with you. But one important point, and I like your example about sodas and the tax. So for my home country, Israel, they had a tax on a sugary drink.
I do.
And you have seen that there have been some research that show that suddenly the obesity and the weight of the kids and so on started to went down.
Absolutely.
So this is a very good a tool. In order, the same with cigarette. When you pay on cigarette $6 instead of $1, suddenly it's more expensive for you to smoke.
You basically, when you add a tax, you have decreased effective availability.
Yeah.
This basically any substance of abuse,
Yeah.
and sugar is a substance of abuse
Absolutely.
and is addictive, okay, obeys the iron law of public health.
Yeah.
And that law goes like this. Reducing the availability of a substance reduces consumption, which reduces health harms.
Yeah.
That is a law.
Yeah, and especially it's not for us that live in the suburbs and we are educated and know what to do. It's more in the food desert, I will call it, where the whole food is like 5 miles from you, and also it's very expensive. So you'll go to McDonald's and buy going back to your apple pie or whatever that you buy there, that it's not good for you.
Exactly.
As a Longevity by Design podcast listener, you understand the value of improving your health for today and for all the years ahead. And if you want to live your healthiest, longest life possible, you need to understand what's going on inside. At Inside Tracker, we take a personalized approach to health span optimization that eliminates guesswork from your wellness plan. Inside Tracker analyzes blood biomarker and DNA data, along with physiomarker data from fitness trackers like Oura Ring, to deliver personalized food, supplement, lifestyle, and exercise recommendations that allow you to take control and improve your health span. And for a limited time, Longevity by Design listeners can get 20% off at the Inside Tracker store. So if you're ready to receive a personal health analysis and data-driven wellness plan to optimize your body for the long haul, then it's time to start inside. Visit insidetracker.com/podcast to get started today. That's insidetracker.com/podcast to get started today.
Sugar is the easy one because the sugar's been added by the food industry for its own purposes.
Yeah.
And that's the one of all of the ROS generators that we could actually take out and fix immediately.
Yeah.
And we have the modeling studies to show how fast and how complete the change in chronic metabolic disease would be. We did one study that was published in BMJ Open in 2017, and the group at Harvard published a study in 2021 in Circulation, showing that getting sugar out of our diet would have enormous benefits in terms of morbidity, mortality, and costs saved. No question. Can we make that happen? Well, like I said, we have soda taxes. Now, there are soda taxes in 6 U.S. cities. There are soda taxes in 28 countries. But there are 207 countries, and there are a whole lot more than 6 cities in America.
Yeah.
Okay, we have a long way to go. People do not understand, and the reason they don't understand is because they still think a calorie is a calorie. We have to fix that.
So
Part of my job,
Yeah. So that's what you dedicate your life to try to.
among other things.
Yeah.
Yes.
Yeah.
That's why I wrote the books that I wrote. That's why I do the work that I do. And it's also why I'm in the entrepreneurial field trying to actually mitigate chronic metabolic disease on a, shall we say, on a population level.
And if, with your permission, I would like to switch gears a bit and discuss the fat, and specifically the different kind of fat. So I know that you believe that there are 3 different kind of fat. So if you can
7.
7. Okay.
7.
So let's discuss those 7s.
7.
And what are their impact on metabolic diseases, and which one is the one that our audience should worry about the most?
Let's do them in order of health to death.
Okay.
Okay?
Yeah, sure.
All right? We'll do them in that order. So the healthiest fat, by far and away, no ifs, ands, or buts, omega-3s. Omega-3s are basically the elixir of life. Omega-3s are anti-inflammatory. They are anti-Alzheimer's. They contribute to neural structure. They contribute to neural function. Okay, they are ways to move lipids around in a rational way throughout the body. Okay, omega-3s. Question is, where do you get omega-3s from?
Mainly from fish.
Wild fish.
Yeah.
Not farmed fish.
Yeah.
Farm fish are omega-6s, and the reason is because wild fish eat algae. The algae make the omega-3s. The fish eat the algae. We eat the fish. Farm fish eat corn. Corn's high in omega-6s. The fish eat the corn, then we eat the fish, so we get an increased load of omega-6s. And the problem is that omega-3s are really only available through fish on the coasts, because the rest of the country, America, It's all farm fish that's available. So this is a problem.
Yeah.
People in the center of the country don't understand this. They need to take fish oil.
Or algae.
Not just any old fish oil. They have to take wild
Yeah.
fish oil.
Yeah.
And you have to look at the label to see whether or not
Yeah.
it's actually from wild fish. So this is a big problem. So omega-3s are extraordinarily beneficial, but they're also extraordinarily rare in the diet, and they're also relatively expensive.
Yeah.
So there's a problem.
Mhm.
Number 2, monounsaturated fatty acids. So oleic acid, like olive oil.
Yeah.
So oleic acid turns out to be the endogenous ligand for PPAR alpha, peroxisome proliferation activated receptor alpha, which is one of the fuel gauges on the liver cell. Makes the liver cell work better. So oleic acid's a good one. The problem with oleic acid, olive oil, is not the olive oil. The problem is cooking in the olive oil. Because if you take the olive oil, which has a very low smoking point, and you fry in it, basically what you've done is you've turned those oleic acids into transoleic acids. You've flipped the double bond. So normally all fatty acids that are unsaturated are cis-unsaturated. But if you turn them into a trans-unsaturated fatty acid by putting enough heat across that double bond and basically isomerizing it into the trans configuration, you can't break that double bond because you don't have the trans-desaturase.
Yeah. So don't try to be too healthy and cook with olive oil. Keep it for the salad.
For the salad, exactly. Number 3, polyunsaturated fatty acids. So this is what's canola oil, rapeseed oil, various other, shall we say, specialty oils.
Yeah.
And they are good unless you eat too many of them, because you actually need monounsaturates for your immune system to function right, because they're anti-inflammatory. And the problem also is because polyunsaturated fatty acids have multiple double bonds, they can be trans-isomerized by heat as well. In fact, there are more loci to be trans-isomerized. And so this is another reason why PUFAs can be a problem if you overheat them, okay, which unfortunately fish fryers like Red Lobster and what have you tend to do, because they tend to keep the heat up very high to fry the fish quickly.
Yeah.
Number 4, saturated fatty acids, so lard. Now, lard has a bad rap. People think saturated fatty acids are the devil, because Ansel Keys, back in the 1960s and 70s, basically said saturated fat was the generator of cardiovascular disease.
Yeah.
This turns out to be complete hogwash. This is total garbage. Okay. He cherry-picked his data, and we now have the data to demonstrate that saturated fats are neither good nor bad. They're cardiovascularly neutral. I'm not saying they're good, but they're also not bad. They raise your LDL, but they raise your large buoyant LDL. And your large buoyant LDL are not the cause of the heart disease. The small dense are. And the small dense are actually what happens to the remnant of the VLDL, the very low density lipoprotein, the triglyceride that your liver made from carbohydrate. The small dense LDL is because of your carbohydrate consumption. Your large buoyant LDL is because of your saturated fat consumption. But it's your small dense that causes the heart disease. And this is why this whole statin debacle is such a disaster, because most people who are on statins for their high LDL don't need it, because the reason their high LDL is high is because they have large buoyance. So what? They don't need statins for that.
But what if you look at the particle and then you know?
Well, and so that's one of the things that I recommend and that you recommend we do, is look at the actual particle size and the particle number instead of just the cholesterol.
ApoB, for example.
Like ApoB, as an example.
Yeah.
For sure.
Yeah.
Number 5, medium chain triglycerides. Now, medium chain triglycerides have gotten a good rap, like coconut oil.
Yeah.
Okay. And they can be, but the problem is that because they are metabolized in a completely different way, they are not absorbed via the lacteals and develop chylomicrons. They go straight to the liver, and they can overwhelm the liver and cause the liver to actually generate liver fat
Yeah,
and
fatty
cause
liver,
insulin
yeah.
resistance too. Adding coconut oil to a high-fat diet, which is what a lot of the ketogenic people are doing, is not necessarily the best thing. Number 6, omega-6s. So omega-6s are pro-inflammatory because omega-6s are the precursor to arachidonic acid. And arachidonic acid is the precursor to thromboxanes, leukotrienes, and eicosanoids, all of the things in the inflammatory cascade. So omega-6 is associated with pro-inflammation, and inflammation is one of the bad guys in terms of all these morbidities and mortalities of chronic disease. Where do we get the omega-6s from? Seed oils, soybean oil, corn oil, etc. So omega-6s are a problem. Now, you need omega-6s because you need inflammation, otherwise you'd be eaten by the maggots. But you don't need so much inflammation that it's going on chronically all the time. And then finally, number 7, the devil incarnate, the absolute worst thing you can put in your body, bar none, trans fats. Trans fats are the truly consumable poison. The good news is the FDA finally recognized that. In 2006, they made the food industry put the number of trans fats per serving on the label, and in 2013, they actually banned them, except they didn't ban them. What they said was that they are supposed to come out of your diet, but you could, and this is the FDA's rule, it's a really lousy rule, if a foodstuff has 0.49 grams of trans fat per serving, you can round down to 0. So you can say something has 0 trans fat, but it's not true. It has 0.49. And if you eat 4 of those, you will die of a heart attack.
Yeah. So why have they done it? Because it's hard to take it out, or what was
It's
the
hard to take out, and the food industry doesn't want it to be
Yeah.
taken out because it's one of the primary preservatives.
Yeah.
And the reason is because bacteria are like refurbished mitochondria. They don't have the enzyme to break that trans double bond either, so they can't grow on it. That's why things that have trans fats don't become rancid. The 10-year-old Twinkie. Well, our mitochondria don't have that trans desaturase either. And so what happens is the mitochondria will cleave off 2 carbon fragments until it hits that trans portion, and now it'll stop. And then the residual will line your arteries in your liver and cause insulin resistance and basically contribute to death.
So you mentioned before fatty liver, and I want to maybe to discuss a bit about the kind of fat that we have in the body. Fatty liver is one, but we have a few other adipose locations. So can you discuss that?
We have 3
Yeah.
adipose tissue depots.
Yeah.
And when you stand on a scale, you're measuring all 3 at once. But in
You
fact,
mean a scale that have a
scale on the
body
floor.
fat percentage?
Yeah.
Yeah.
No, I mean like
Weight.
weight.
Yeah, but weight is not only fat; it's also muscle.
Right, it's
and-
everything.
Yeah.
But, I mean, people think they're obese because of what the scale says.
Oh, you're talking about now about BMI. Yeah. Okay.
BMI or weight.
Yeah.
Either
okay.
or.
Yeah.
So there are 3 fat depots that contribute to adiposity.
Yeah.
Let's take the obvious one, subcutaneous or big butt fat.
Yeah.
Okay. Big butt fat is cosmetically undesirable but metabolically inert. This is where your body wants to put
Mhm.
excess energy. It is designed to store excess energy.
And also maintain your temperature because it's a good insulator.
Absolutely.
Yeah.
There are a whole bunch of reasons why having subcutaneous fat
Yeah.
is good.
Yeah.
And in fact, there are diseases of reduced subcutaneous fat. They are called lipodystrophies,
Mhm.
and they make you very sick.
Mhm.
High morbidity, high mortality.
Yeah.
Having too much fat is a problem, but having too little fat is equally a problem, and maybe even worse.
Yeah, absolutely.
So people think it's only about obesity. No, it's about the type of adiposity.
But also, each of our cells is covered by fat. Without we cannot live without fat.
Totally.
Yeah.
Absolutely.
Yeah.
Cell membranes are fat.
Yeah.
No question. Okay, cholesterol comes in the fat. You need cholesterol.
Yeah, even estrogen and testosterone are fat.
Of course,
Yeah.
they're steroids. They
Yeah.
came from.
Yeah, they came from fat. Yeah.
They came from.
Yeah.
Absolutely, all true.
Yeah.
So you can't just do away with fat. This notion that you can eat fat free, a joke.
Yeah.
Okay, but we didn't know that 50 years ago. Unfortunately, there are still people who are teaching that,
Yeah.
which is part of the problem.
Yeah.
So subcutaneous fat is not the problem. And here's how to explain it. Your fat cell has a fat vacuole where you eat. You put some fat into the fat vacuole, grows. You eat. You put some more fat into the fat vacuole, grows and grows and grows, until finally the perilipin border that surrounds that fat vacuole can't stretch big enough for as big as the fat vacuole got.
Mm-hmm.
When that happens, then the grease starts to leak into the cell
Yeah.
for the adipocyte, chokes off the adipocyte, kills the adipocyte. You can actually see it on tunnel staining on biopsy.
Yeah.
What happens then is that that cell releases cytokines, which recruit macrophages, and the macrophages come in to clean up the grease. They release cytokines, and then those cytokines go into the bloodstream. Now, when the cytokines go into the bloodstream, where are they going? They're going to the systemic circulation because subcutaneous fat drains into the inferior vena cava, drains into the general circulation.
Yeah.
How many liters of blood do you have?
Around 6 liters.
6 liters, that's right. So relatively large volume of distribution.
Yeah.
You would have to generate a whole lot of cytokines to get the concentration up when you have a volume of distribution of 6 liters.
Yeah.
How many pounds of excess fat can your subcutaneous adipose tissue store before you get sick? About 22 pounds, 10 kilos.
Wow.
Give or take.
That's a lot.
Fair amount.
Yeah.
Okay. That's your spare tire.
And if you look at fat percentage, if a person that is, let's say, 200 pounds, it's only around 10%. So
That's right. And so not necessarily a big deal.
Yeah.
Let's take fat depot number 2, visceral fat, big belly fat.
Yeah.
Okay, now big belly fat is not big butt fat.
Yeah.
Big belly fat is not due to calories. Big belly fat is due to cortisol, stress.
Yes. Yeah.
And the reason we know this is because you can take people who are clinically depressed with major depressive disorder, who have to be admitted to the hospital to keep them from killing themselves,
Mhm.
suicidal ideation, okay? And they're not eating. They're anhedonic because they want to die,
Mhm.
okay? And we have to save them from themselves. And we admit them to the hospital. We put them in an MRI scanner, and we see what's going on in their belly. And their subcutaneous fat has dwindled down to nothing because they've lost all this weight because they're not eating.
Yeah.
But their visceral fat has grown. How'd their visceral fat grow when their subcutaneous fat has gone down? And the answer is because the cortisol drove the visceral fat, not the calorie.
So basically, it's stress dependent.
It's stress dependent.
And what is the why visceral fat is bad? What is the effect on the body?
So the visceral fat, so the adipose tissue and the visceral fat will store the excess energy,
Yeah.
okay, that was put there by the cortisol.
Yeah.
And then it will leak and it will generate the cytokines. And then those cytokines will end up at the liver, okay, because they didn't go into the systemic circulation. Remember, the volume of distribution was 6 liters.
Yeah.
They go into the portal circulation, and the volume of distribution there is 250 cc's,
Mhm.
a quarter of a liter. The same amount of fat in the visceral component will generate 24 times the concentration of cytokines as the fat in the subcutaneous component.
Mhm.
And so that will drive insulin resistance at the level of the liver, and that is what makes you sick. So how many pounds of visceral fat can you store before you get sick?
Not a lot. It's not.
3 or 4 pounds.
Yeah.
Now, can you measure 3 or 4 pounds on the scale?
No, you can do it in DEXA. DEXA
can do it.
can show it. Yeah.
That's right. DEXA
Yeah.
can show, but not your
No.
scale.
No. But you can see it in your eyes.
We could see it in your waist circumference,
Yeah.
maybe.
Yeah. Yeah.
That's right.
Yeah.
Okay, and now finally, fat depot number 3, liver fat.
Yeah.
And that's ground zero. That's where the action is. Okay? The liver is not designed to store fat. It has no capacity to store fat. It doesn't have fat vacuoles. It just has lipid droplets. Okay, there's no perilipin border around the fat droplet in a liver. It's going to choke off the liver much quicker. How many pounds of fat can your liver store before it gets sick?
I would say very little, maybe 1 pound.
Half a pound. Half a
And it's also, from what I know, you're the expert, it's a relatively new phenomena to have a fatty liver. If you look at it like 50 years ago, almost nobody had a fatty liver.
The very first case of non-alcoholic fatty liver disease was
Yeah.
described in Mayo Clinic Proceedings 1980
Yeah.
by J. Ludwig.
So
Not
45,
David, but J.
44 years ago. Yeah.
44 years
Yeah.
ago. There was no liver fat
Yeah.
before that other than alcoholics.
Yeah. Makes sense.
If you had liver fat before 1980, you were an alcoholic.
Yes.
But today, 25% of children have liver fat, and they don't drink alcohol.
Yeah. So it's basically the excess of the subcutaneous going to the belly fat, and then that's the excess going to the liver because you don't have where to store it.
Well, no. There are different things that deposit the fat in different places.
Yeah.
So insulin will deposit it in subcutaneous fat.
Yeah.
Cortisol will deposit it in visceral
Yeah.
fat. What deposits it in liver fat?
I don't.
Sugar and alcohol.
Okay.
Your liver fat is sugar and alcohol. And the reason is because they are mitochondrial toxins, both of them.
So I think that's a good segue to talk about sugar and fructose and why fructose, in your opinion, is so bad and glucose is not. Can we discuss
Absolutely.
that?
Of course, glucose, fructose. 2 sugars,
Yeah.
2 monosaccharides. When you put them together, you have sucrose, table sugar, cane sugar, beet sugar, the stuff you put in your coffee. Okay. When you keep them separate, you have high fructose corn syrup.
Yeah.
That's the difference. Okay. So sucrose is glucose and fructose bound together, and high fructose corn syrup is glucose and fructose unbound, free.
Yeah.
That's the difference. Glucose and fructose are not the same. Glucose is a 6-membered ring. Fructose is a 5-membered ring. Now, they're both C6H12O6. They're isomers. That's true. But they are not metabolized the same way.
Can you
Another reason
explain?
a calorie is not a calorie.
Can you explain to our audience what is isomer and what is the difference
An
between it?
isomer is a different form of a chemical that has the same composition but a different structure.
So basically, the 3D is a bit different, but the molecule is exactly the same, correct?
Well, no, the molecule is not the same.
No. I mean, the order, the amount of carbon, and the
The amount of carbon, the amount of hydrogen, the amount of
yeah.
oxygen is
It's
the
the
same.
same, but just the structure is
The
different.
structure is
Yeah,
different.
yeah.
And so they're handled differently.
Yeah.
Another reason a calorie is not a calorie.
Yeah, no, absolutely. It's
Turns
more
out-
complex, yeah.
But the food industry will tell you a calorie is a calorie and a sugar is a sugar.
Yeah.
Right? Not true. It's completely false. And anyone who says it is a fool or a liar.
Let's go into that. Can our cells metabolize fructose, or they can only metabolize glucose?
Every cell in your body can metabolize glucose.
Glucose, yeah.
Glucose is the energy of life.
Yeah.
There's no cell on the planet that cannot metabolize glucose.
Correct.
Glucose is across the board. Pick your species. Glucose is the energy substrate of choice.
Okay.
No argument. Fructose is not. Fructose is a holdover from our plant ancestors. Only plants make fructose.
Okay.
Okay. Fruit sugar.
Yeah.
Okay.
Yeah, fructose.
Fruit makes sugar. Fructose.
Yeah.
Fructose is the sweet molecule.
Yeah.
Sugar. Fructose is what makes sugar addictive.
Yeah.
It's an addictive molecule of sugar. Okay. It goes to a different part of the brain than glucose does. They have completely different actions and activities. And there's only one type of cell in the body that can actually metabolize fructose, the liver. But it has a limited capacity to do so. It can metabolize some, But when you overwhelm it, it can't metabolize all.
So when it metabolize,
Just like alcohol.
when it metabolize it, it's transfer it to glucose or transfer it to fat?
No, it translates it into pyruvate,
Okay.
and then the pyruvate should enter the mitochondria
Okay.
to be burned off to
Okay.
carbon dioxide and ATP. But the Vmax, the maximum velocity of the tricarboxylic acid cycle in the mitochondria, can only go so fast.
Yeah.
It's fixed.
Yeah.
If you supply the substrate faster than the TCA cycle can turn, then the mitochondria can't metabolize it, in which case the excess gets thrown off out of the mitochondria as citrate through a process called the citrate shuttle, leaves the mitochondria, and then the enzymes in the cytosol will turn that citrate into first acetyl-CoA, then malonyl-CoA, and finally to fatty acyl-CoA. You have built a fat
Yeah.
out of sugar. This process of turning sugar into fat is called de novo lipogenesis, or DNL, and fructose is the preferred substrate for DNL. Glucose is not.
Okay, so for our audience, what happened is only one kind of cells, the liver, or one organ can metabolize fructose,
That's right.
but it cannot, there is a limit of how much fructose it can. So if you overload, the fructose will go, a chemical modification will become a fat that will be stored, I assume, in the three adipose organ that we discussed, and that might be the problem of a overload of fructose that we see today.
Exactly right.
Okay.
Exactly right. And the thing is that it's being made in the liver. If it gets exported out of the liver, then your triglycerides go up.
Yeah.
In which case, then you have a increased risk for heart disease and adiposity, obesity. If the triglyceride doesn't make it out of your liver, now you have a lipid droplet. Now you have fatty liver disease.
Yeah.
And now you have a risk for diabetes, Alzheimer's, and every other disease.
Yeah.
Bottom line, if you have a chemical that you have limited capacity to metabolize, and when presented with excess, can cause cell damage, cell dysfunction, cell death, organ dysfunction, and human death. What do we call that?
I would say that it's a toxin, isn't it?
That would be a toxin.
Yeah.
That is exactly what that would be.
Yeah.
Fructose is a dose-dependent hepatotoxin.
Yeah. But I think that it's true for everything. Alcohol in moderation is okay, but if you drink, again, I'm not drinking any alcohol, but even if you drink 1 cup a day, that's okay. But if you drink
Not a cup.
not
Shot.
a shot, yeah. But if you drink it,
cup, you got a
yeah.
problem.
But if you drink too much, it's again, it's going to the liver and it's toxin. The same with anything else that you eat. It's all should be on moderation. And maybe my follow-up question for that is, fructose, as you said, is a sugar that comes from the plant. We have fructose in an apple, we have fructose in other fruit, but I think that what is the difference is, again, we're going back to the fiber.
The fiber.
So if you have the right ratio between fructose and a fiber, that's okay. Because I don't want our audience to come and say, hey, fructose is horrible. It's horrible if it's coming from a processed food, correct?
It's horrible if it's added sugar.
Yeah, so it's a process, basically.
Exactly.
Yeah.
Well, added sugar means processed.
Yeah. No, so I think that we agree. Eat up. Nobody should come from this podcast and stop eating apple. Apple is great.
I am totally for fruit. I am for dessert.
Yeah.
How about that?
Yeah.
For dessert. I am not for dessert for breakfast, lunch, snacks, and
Yeah.
dinner.
Absolutely.
But here's the problem. In America, the National School Breakfast Program breakfast, which 29% of children
Yeah.
in America consume because they're getting their breakfast at school because they're low income and they wouldn't get any breakfast if they didn't get it at school.
Yeah.
29%. Okay. What is the standard National School Breakfast Program breakfast?
I would say McDonald's apple pie.
Well, it is a bowl of Fruit Loops and a glass of orange juice.
Yeah.
That is what it is.
Yeah. And I assume that the orange juice is not a squeezed orange juice. It's like a lot of sugar.
It's.
Yeah.
So when you do the math on that, that's 41 grams of sugar The American Heart Association says that the maximum for children should be 12 grams of sugar for the whole day.
Yeah.
This is 41 grams of sugar, and it's just breakfast.
And the kids are small, so it's not for adults, so they need to eat less.
Exactly.
Yeah.
So this is what is wrong with children today.
Yeah.
And this is why childhood obesity is going through the roof. It's also why childhood ADHD is going through the roof. It's why autism is going through the roof.
Yeah.
It is why virtually every chronic disease that we see in adults now occurs in children.
So how can we change it? How can we change why we are allowing that? Why don't we? If you think about it, smoking is a great example in the US.
Yeah.
That, 20, 30 years ago, I don't know how many percent, but let's say 20, 30% they smoked. Now it's much less.
Right.
And when you go to Europe, you see much more smokers. So we fought it very well. Why can't we do that?
Well, we could if we had the political will.
Okay.
It took a long time in America to get the political will to fight the tobacco industry. In fact, we didn't really have that political will until we exposed the tobacco industry. And Congress called the 3 tobacco executives up to Capitol Hill and asked them, is nicotine addictive? And they all said, no, it's not, but we knew it was. Okay, and so the emperor had no clothes.
Yeah.
And that made a big difference. But the other thing that made a big difference was secondhand smoke.
Yeah.
Okay, so a lot of people said, personal responsibility. You take the risks, you suffer the consequences. Okay, and cigarettes were the perfect example.
Yeah.
So here's a question for you, Gil. Look, you're Israeli. You don't know American history very well. Who invented personal responsibility? The tobacco industry.
Mm.
People think, oh, Declaration of Independence, Constitution, state legislatures. Not at all. Okay? Magna Carta. No. The tobacco industry. In fact, personal responsibility was never mentioned anywhere in any document, anywhere until 1962 by the tobacco industry. And the reason was because they were getting killed on the science of cigarette smoke and lung cancer. And they had to invent another reason for you to smoke. Well, nobody put that cigarette in your mouth. Nobody lit it for you. Personal responsibility, assumption of risk, your fault. Freedom of choice, this notion that nanny state, you can basically do whatever you want. Freedom of choice is really freedom to blame. Okay? And the fact is, sugar fits the same rubric. Now, people think sugar is calories, and calories is food.
Yeah.
Wrong. Can you name 2 calorie-containing items that we consume that are not food?
2 items?
Mention them both.
2 items?
2 items that contain calories but are not food.
I think you said water, correct?
Well, that doesn't have calories.
Yeah, but you can warm it and it
Still doesn't have calories.
Okay, no, I don't know.
We've mentioned them both.
Okay.
Okay, alcohol
Okay.
and trans fats.
Yeah.
Okay, both have calories. Okay, alcohol is 7 calories per gram.
Yeah.
Trans fats are 9 calories per gram, but neither of them are food. Trans fats used to be food until we actually learned the science of them. And now they're not.
You mean by law? I don't know.
By law.
Yeah. Okay.
They're not food.
Yeah. Okay.
Well, it turns out sugar is not food either for the exact same reason. In order to, not to belabor this, but what is the definition of food? So if you go to the dictionary and you look up the definition of food, which I have done.
Yeah, I'm sure.
Okay. Here's the definition, straight from the dictionary. Substrate that contributes to either the growth or burning of an organism.
Yeah.
Growth or burning.
Yeah.
Just like we talked about earlier.
Yeah.
Okay. Those 3 enzymes. If a substrate contributes to burning, it's a food.
Yeah.
But fructose inhibits mitochondrial function.
Yeah.
It inhibits AMP kinase, it inhibits ACAD-L, acyl-CoA dehydrogenase long chain, and inhibits CPT1, carnitine palmitoyl transferase 1. Those are 3 enzymes that are necessary for mitochondria to function. What about growth? Turns out fructose inhibits growth. And we have that data in rodents. My colleague from Jerusalem, Hebrew University, Dr. Efrat Monsenigo Ornan, who runs the Department of Nutrition at Huji, demonstrated that fructose is a direct inhibitor of skeletal, cortical, trabecular bone growth.
Yeah.
Okay. And we have the data in humans too to demonstrate that ultra-processed food actually inhibits growth. If a substrate does not contribute to growth and does not contribute to burning, is it a food?
I agree with you. I think that it's
Well,
again, in your definition, it's not food, and I agree with you that it shouldn't be all the additive sugar is pretty bad.
well, if something is both toxic and addictive, like alcohol,
Yeah,
like tobacco,
yeah, it shouldn't be.
we regulate it.
Yeah, yeah,
Well, sugar meets both those criteria. It's
Yeah.
toxic and addictive,
Yeah.
and it's ubiquitous, and it also has negative impacts on
Yeah.
society. Therefore, it should be regulated. So this is the argument for the policy people that
Yeah.
we're trying to put forward.
Makes sense.
And, well, we have soda taxes. It's the first step.
Yeah.
More to come.
No, I agree, and I think that again, if we are trying to package it as a simple take-off message for our audience, again, sugar is not bad when it comes from a natural source. So the apple,
Because the fiber
exactly.
reduces the absorption.
Yeah. But all the additive sugar is bad, and the bottom line is, I always tell our users or customer or everyone that I'm talking with, everything that come in a package is not good for you.
That's right.
Yeah. So try to consume it as little as possible. And what you are doing, Rob, which is great, let's try to have a policies, regulation that will prevent people that are not educated to consume it, because it's very cheap, it's easy, and it's make a lot of money for the food industry, so they are happy about it.
An easy way to explain this to the public.
Mhm.
If a food has a label, it's a warning label.
Yeah.
Real food doesn't need a label.
Yeah.
Do you see a food label on broccoli?
No,
Do you see a food label on a radish?
no,
Do you see a food label on a pineapple?
no. You know what is that?
Because you know what it is.
Yeah.
Okay? It's only when something's been done to
Yeah.
the food that you need a label. Processing requires a label.
Yeah.
If there's nothing processed about it and it's Nova 1, there's no label.
Absolutely.
We need to be more cognizant of what happened to the food than what's in the food.
Yeah. Yeah.
All food is inherently good. It's what we do to the food that's not.
Yeah.
And that is a new concept.
Yeah. Yeah, and I think that is a great summary for our discussion. Time flew by, and unfortunately, we are out of time. But before we'll wrap up, I would like to ask you one question, and I assume that I know what will be your answer for this question. But anyway, I will ask it. And the question is, what would you recommend our audience related to longevity? What is a 1 or 2 intervention that you will recommend them to do in order to live better longer?
I totally get it. And by the way, I am the chief medical officer of a longevity company to boot. So I do understand this. Okay. There are 8, count them, 8 pathologies, subcellular pathologies that contribute to morbidity and mortality. The goal is to stave off those 8. I'll name them.
Okay.
And you've heard of all of them and you know them all. You know them all. Your audience may not.
Yeah.
1, glycation. 2, oxidative stress. 3, mitochondrial dysfunction. 4, insulin resistance. 5, membrane instability. 6, inflammation. 7, methylation. 8, autophagy. Every one of those causes cell damage. And when you have cell damage, you get human damage. When you have human damage, you get death. The goal of longevity is to stave those 8 off. I liken it to you are born by the grace of God with a spanking brand new fire red Ferrari. Everyone is.
Yeah.
The goal is to keep it from becoming a jalopy. Okay. The problem is you are not given an owner's manual and you are not given an insurance policy.
Yeah.
Your job is to keep that Ferrari humming and purring like you got it at the beginning, at the start. Okay? The question is, how do you do that? Glycation is like carbon deposits on the intake manifold. Oxidative stress is like rusting. Mitochondrial functions like defective transmission. Insulin resistance is like a carburetor that's sticky. Membrane instability is rotting fuel lines. Inflammation is a hood fire, under the hood fire. Methylation is like having a buildup on the spark plugs. Instead of running a V8, you're running a V2. And finally, autophagy is like oil sludge. You would never, if you had that fire red Ferrari, let any of those things happen to your beautiful fire red Ferrari baby, would you?
No, I won't.
No, you won't.
So what is the intervention that we should do?
So the question is, what causes those 8? And the answer is, every one of them is driven by food. And each one is driven by a different aspect of food. But they are all driven by processed food, ultra-processed food. They're all made worse by ultra-processed food. And they are all made better by real food.
Yeah.
Real food's where you start. Now, is exercise important? Sure. But exercise only fixes 4 of the 8. Okay? It fixes mitochondrial dysfunction. It fixes insulin resistance. It fixes autophagy. And it fixes inflammation. That's good. I'm for exercise because it fixes 4 of the 8. But only food fixes 8 of the 8. Okay? Food's more important. But diet and exercise. What kind of diet? Well, real food. What kind of exercise? Anything that gets your mitochondria moving. Okay? That can be walking. That's my solution to longevity.
Okay. So basically what you're saying, again, I'm trying to communicate it to our audience. Eat a real food, not a processed food, and exercise and walking is good enough.
Walking is good enough.
Yeah. Don't go crazy. You don't need to go crazy and climb the Everest.
Walking is good enough.
Yeah. Okay. That's a great summary. Thank you so much, and appreciate your wisdom. And that was a fun interview. Thank you so much.
Oh, my pleasure, Gil. Thank you.
Thanks for listening to Longevity by Design. Please subscribe to this podcast on Apple, Spotify, or YouTube. Longevity by Design is powered by Inside Tracker, a personalized health optimization platform that helps people improve their lives by improving their bodies from the inside out using personalized, science-backed recommendations for nutrition, supplements, and lifestyle changes. To learn more, visit insidetracker.com/podcast.